So Thermino I and IPV. So this is our module 2. So this is our units that are compatible with. It's an indirect model which you'd fit with a gas boiler, basically. Gas boiler is your Thermino I, gas boiler and solar PV for IPV. Again, it's the same cutaway, but you're always going to have a dual circuit, 4 ports for these units. You're going to have cold water in, hot water out, but also you've got your flow and your return going back to your heat source as well. Okay. So again, with that in mind, you've got your cold water in. This will be an IPV setup. All right, just based on the flow and return pipes and the cold in and the hot out. But that's the important thing there. We need a 63 minimum to ideally 65-degree flow temperature going into the battery at this point. So you could set your boiler thermostat to 65, but what's your heat loss is going to be on the pipework? Because I can guarantee you your central heating pipes are not going to be lagged throughout the system. You might get a little piddly bit here above the kitchen worktop or something, but within that house, your flow returns are never going to be insulated. I think in my time in the heating industry, zero central heat systems were fully insulated. Maybe new builds, it's different.
That's a minimum flow temperature.
Yeah.
Is there a maximum flow temperature?
Yes, 80.
80.
Yeah, no more than 80. So, I mean, your boiler thermostats will be set to about 82 anyway.
But I'd hope not.
Yeah.
I fit priority domestic hot water systems generally, so the boiler will do hot water and hot water only. So set the maximum flow temperature on that to 80 degrees, and then I'm okay, am I? So it can do whatever it.
Yeah, you can do that. So there's two aspects to that. So yeah, I've got 63 to 65 there as a minimum, but there is a link on our PCB. So if you look at this bullet point here, link 3 in the PCB, that basically determines the set points of the Thermino I and IPV from an external heat source. So if you've got, we'll have a picture later and I can show you, but link 3, basically that's set from your external heat source, that set point will be 65 degrees. So that's why we say 65.
Okay.
If you remove that link, it then starts looking for a set point of 75-degree flow temperature. So if you set your heat source to 80, you would be looking to remove link 3.
What's that doing then? That's changing the timings on the PCB to how quickly it's recovering. Or
it's basically setting the temperature set point. So instead of cutting off once the battery is up to 65 degrees, it's allowing it to run. It's allowing the boiler to run longer to achieve a 75-degree flow temperature.
Okay.
A 75-degree set point. Sorry. So yeah.
On the phase change material.
Yeah.
Yeah. Okay.
So if you're putting 75 degrees in, then the battery will be up at 75 degrees.
Okay.
Basically.
But it's still. Are these the same? So the storage capacity is 14 kilowatts on a 150. Was that right from before?
Yeah, on a 300.
On a 300. So sorry. So this I version, it's still 14 kilowatts on a 300.
You've got 14 kilowatts of storage within that battery. So
even if you push that temperature up,
precisely if you push the temperature up. If you push it down to 65, you're going to get a little bit less.
Okay. And so your recovery time is quicker then, or not really?
Recovery time, yes,
because your water temperature's higher, isn't it?
Yeah, you've got a higher flow temperature. Yeah.
Yeah. Okay. Cool.
So heat up much faster. I mean, if you've got a 75-degree flow temperature, a 14 kilowatt, Thermino 300, and you've got a 14 kilowatt boiler, say, you're pumping 14 kilowatts into that. you're going to be up to temperature within an hour maximum. So really, you know, you've got 14 kilowatts. You put in 14 kilowatts, that's you up to temp. If you can achieve 14 kilowatts with a 65-degree flow temperature, then you've got the same thing, but you're not achieving that higher set point.
So the overall capacity will be slightly lower for the customer.
Yeah.
A hot water outlet.
Yeah, basically. You're still going to have, so yeah, 65. You're only getting out what you put into it, aren't you? So, but again, that's one of the things. So one of the functionality, that's the functionality of it. But what is it like on the customer side of things? They might think having the boiler thermostat set that high is too high for them.
Yes, I mean on a traditional system where you've got your boiler thermostat dictating the overall flow temperature of the system, you're better to set it as low as possible. But on a modern or a sensible priority domestic hot water system, the boiler will run to as much as it can in order to heat the water.
Precisely. Yeah, I mean, this is a bit of an old hat boiler now, indeed, but that boiler stat dictates your flow temperature to your radiators and your hot water circuit. So if that's the case, you just have to make sure the customer's happy, because if you turn that down, I'm more thinking if you're turning it down to achieve that 65-degree flow temp, that's going to have an effect on the customer's radiators.
Yes.
And you'll know that first thing they'll do is check that radiator. So yeah, but yeah, the flow at the battery is what we're looking for. I mean, I've dealt with installers and they've got a temperature display in the boiler, and they say, oh yeah, I've got 75 degrees on the boiler. Well, they're only getting 60 here. You know, they're not checking this. This is what we're interested in. We're not bothered about up there. Well, we are, but it has to, whatever happens up here is possibly affecting there. And with that incident, I think the display was about 5 degrees out, and the bypass was open as well. So, you know, that's your circuit. That's where your heat's going. It wasn't going in there. So yeah, so that's the sort of basic requirements for the iron IPV. There's not much change with the specification table. The V40 is a bit less. Basically, as you were saying there, George, you've got less going into it, and also you've got that heat exchanger is more packed because you've got a secondary coil in there as well, so you've got less capacity of that way. That coil's taking up space in phase change material, if you think about it. Whereas in the E's and the EPVs, that secondary coil's not there. So essentially the space is being filled with the phase change material. Heat losses are the same. Yeah. That annoys me as well, why we've got that in our manual. 45 to 55. I mean, you can get a blending valve that ranges from 35 up to 50. It's really down to the customer requirement. I chatted with a customer a couple of weeks ago and he was happy with 37 degrees. So it's up to the customer really what they want. And then the flow rates all stay the same as well. So mechanical connections for the Thermino I, that's your flow pipe, that's your return pipe, that's your cold mains in, that's your hot water out. But if you look, the two hotter pipes are both together and the two colder pipes are both together. So you would never have your flow pipe here and your hot pipe out there, basically. It just affects how the thing's heating up and discharging. But when you go to the Thermino IPV, the pipework changes. So again, that's all to do with how the unit's been charged. This is charging top to bottom, and this is discharging bottom to top. Yeah, bottom to top. And this is charging bottom to top and just charging top to bottom. So again, the point is, if you're working on lots of Thermino I's and you come across an IPV, just double reference the manual, just to make sure you've got the right pipes going in the right connections. Basic schematic of an S-plan. 2-port valves going into your flow pipe, your return pipe, your system components, the vessel. The question we get asked is a hot water flow regulator. Number 15. It's basically just a valve to limit your flow rate out of that TMV. But you can do that. You could probably limit your flow rate at your pressure reducing valve as well at the start. So it's just another way of doing it. So W plan, we're not optimized for a Y plan mid-position valve. So this is essentially, basically, it will divert to hot water, and then at rest, it'll be feeding your central main system. So that's an important thing with this setup for a 3-port valve. When that battery is calling for heat, the valve motors open to the hot water circuit. And then once it's reached temperature, it then sits in central heating mode at rest. So, pardon me, the reason for that is if you've got any pump overruns or anything running, you'll just deplete that store. Other interesting one, again, it was let's go to the IPV. So I had an IPV, customer had a full charge, fully charged battery from the PV, whatever. They put their heating on, and then that battery started to reduce in temperature. The customer's saying, I've got capacity issues, what's going on here? Again, it's a brand new battery that was fitted onto the existing system. I went out to look at it, and I said to the plumber on site, check your zone valve, make sure your zone valve's not passing. Nah, no problem, nothing wrong with it. I go there, I get my temperature clamp, stick it there onto the flow pipe. And when we put the heater on, that zone valve was passing ever so slightly, and it was creating a movement of water. So essentially what it was doing is it was moving that cold leg of water through the battery. And it was the battery was recognizing that, and it was exchanging its heat with that cold leg of water. And then the LEDs were going from 100% to below that. So that's what the problem was, passing zone valve. But it just shows you how sensitive the phase change material is to heat and everything. I mean, that only got picked up because it was an IPV, and we've got the set points quite high for that. If that was a Thermino I, it wouldn't have been picked up. The Thermino I's got, again, it's 20% loss of charge. It'll create that demand to open up the zone valve. Again, we've got a 5% loss of charge, and it'll create that demand. Which is an interesting point, actually. The 5% loss of charge. So, Thermino I, 20% loss of charge. It'll then activate your zone valve and bring on your heat source. Your IPV, it'll only ever charge up to 85% from your heat source, and it'll leave that last 15% to be charged from the element. So whether that's from PV or a time boost, that's what will happen. So if you've got a Thermino IPV, the customer's not getting PV fitted until maybe a year from now. They just have to be aware they're only ever going to get an 85% charge from the boiler. It'll wait for that 15% to be charged from the element. So that can be done from you can still fit a timer to bring the element on, because the customer might have an off-peak tariff that they want to utilize, and you can utilize that by using your solar diverter or a 16 amp rated timer. But it's just to let you know that's the functionality of it.
Even in the winter, and even in times where there's not a lot of PV gain, you'll only ever get 85%.
Yeah, 85% charge from the boiler. So what you'd have to do in the winter time is set a time boost.
Or you need to size that unit. You need to upsize that unit.
Yeah, to
kind of cover the hot water load at 85%, like you would a solar thermal system.
Mm-hmm.
Size the cylinder based on the kind of boiler volume.
You could do that. I mean, the other way about like I say, you could you would set your time boosts in the winter time anyway, and you could have it coming on. So say you had your timer for the hot water circuit for the boiler set from, I don't know, 6 till 7 in the morning. You could set a time boost for 15 minutes at the end of that, or half an hour at the end of that, to then boost it up to 100%.
Okay. I know we're not on heat pumps yet, but is the heat pump version the same as that?
On the, yeah, for the IPV version, yeah.
That's almost backwards though, isn't it? Because you'd rather use your PV to run your heat pump and then get more kilowatts out of your heat pump.
So then you would just put a standard
standard one in and just
standard heat battery, basically. Yeah. Again, it's we just create the functionality for the customers to choose.
No problem.
But there's lots of different ways. I mean, we'll cover the heat pump one. There'll be more.
Yeah, no worries.
Questions for that. Yeah. We'll cover this. You know about the system components, all goods, electrical connections. So that's the Thermino I. So, but your standard one, as I normally call it. So you've got your 3-core flex, which comes out live, neutral, and earth, coming at your double pole isolating switch. Minimum rate is 16 amps, fed by a 16 amp supply. The Wago terminals here are different. So you've got terminals 1, 2, 3, and 4. 3 and 4, that's your control circuit for the boiler. 1 and 2, it's still a volt-free contact circuit, which you can then run 2 separate. You run a 2-core from 1 and 2 to a switch. So if if there's ever a problem with the boiler, the customer still has that electric functionality. So it's like an old school immersion switch, but it's just a 2-core. There's no power source there whatsoever, because that's still volt free. All right. So, and this is interesting as well. You do have to fit 2 separate 2-cores. If you fit a 4-core, now this is, I don't know if this is a bit mental when I first came across it. The magnetic field from 3 and 4, when there's a signal demand, affects your volt-free circuit. It makes the magnetic field from here makes the circuit here, and it starts bringing the element on. So what happens is it starts to chatter back and forward, element on, element off, element on, element off, till eventually the element will just stay on. So that's why you have 2 separate 2-cores to separate that. So both sides are fully insulated. It's a common thing, but it's easily figured out. So, so your wiring diagram, Thermino I S plan. So again, live, neutral, and earth. You've got your volt-free circuit for your immersion. That's obviously somebody's left that on by mistake. Turn that one off. So that's the other thing. If you leave that on, that will then prioritize the element circuit, and it will disengage your external source circuit. Okay, so that's important when you're commissioning, because you might want to just check your immersion's working. Just remember and turn it off. Again, what will happen is signal demand from your timer, and here, relay 2's energized, then sends that signal out to the brown of your zone valve, and then it'll motor open, and the rest is history.
If I have a boiler that needs to look at the temperature of the cylinder, how does that work?
If
I have a boiler with an internal diverter,
yeah,
that looks at a demand from a cylinder sensor.
So are you talking about a V-Smin or something?
Something like that, yeah. I mean, I know I've got a floating contact in there that I could potentially use across that 3 and 4, but it would need to see a temperature. So I could tell it to go into hot water mode through the floating contact, but then it needs to see what it's doing.
Yeah, I know the V-Smin, certainly they've got a separate module box or something that you have to have fitted.
What it needs to see the cylinder temperature. Anything else, like the demand you can get round, there's workarounds with that with relay boxes and stuff, but it needs to physically see that temperature.
Yeah.
So it's not just a demand on a 2-port. It needs to go, right, well, it's 40 degrees in there or 60 degrees in there, or to control its kind of output, as it were.
Yeah, we don't have that functionality because this is a make and break circuit.
Yeah, it's just a contact.
So yeah, it's just a contactor basically. So you'd have to, again with the V-Smin, I spoke to one of the technical managers there about this very thing, and the installers had wired it incorrectly. And what the guy had, I can't remember the name of the box now. There's some sort of control box that had a module board in there, and you put the resistor wire into that.
Right. Okay.
Don't ask me how it works.
Oh, from your board, basically. So it might
so we would
or sensors.
So basically, we were wiring 3 and 4 into this module board.
Okay.
And somehow that box was able to transfer. I don't know how it was working, but it was able to basically send the resistance back to the boiler.
There's no resistance on it, is there? It's just it's just open and closed.
Yeah, make and break. That's all it is. So yeah, in that case, yeah, I mean, we're not gonna.
I'll have a look at some settings. There might be a way to just say run up to X amount, or yeah.
The only way
I can speak to him with that. That's fine. But I can't put a temperature sensor inside one of your heat batteries.
The only way maybe get around it would be fit it on the return pipe or something.
Okay. Yeah.
Which would be here. So yes,
they'll close up to the same, or because the trouble is the boiler will try and keep a delta between flow and return.
Yeah.
So that's fine. I'll have.
But then once that return starts coming up to temperature, the boiler will modulate down anyway. Yes. So depending on what you have that set to, if you set that to 65, you're maybe going to have I don't know, if you've got a 5-degree delta, 70 going in here, 65 coming back. That's fine.
And the heat pump does the same. It just wants an on-off. It doesn't need to know.
The heat pump's a bit different, so we'll
okay.
We'll talk about that.
We'll get to that. So that's cool.
One thing at a time. I can't multitask, George. So but that's essentially how it works. So yeah, these kind of, you need to speak to the boiler manufacturer about that one, and if they've got a fix for it, that's the way I would go down. But yeah, essentially that's your control circuit diagram for an S-plan. So signal demand, dink into 3 out of 4 into the Brownier zone valve, and then the rest is history. So your wiring diagram for the Thermino I 3-port. So again, this is a 3-port valve. I mean, the problem we've got is we don't have a hot water off, so that's why you can't utilize a mid position. That's the official version, but we do have a spare connection here, so which is your common normally closed. So you could potentially use that as a hot water off. You'd have to run a separate wire from here back to your wiring center though to utilize that. Standard wise, we don't have any official guidance for that, but you could potentially use that spare connector for a hot water off. All right. But again, what we're doing here is signal demand from the timer. That then sends out and it motors open that valve to hot water mode. And that's the other thing about a mid-position valve as well. If you've got it in mid-position, say that battery is just below reaching maximum temperature, so there's still a demand, and then the customer puts the heating on, you might get an influx of cold water going through that hot water circuit. So it might just take a little bit longer for that battery to reach temperature. So that's the other reason why they don't like mid position. They just like it diverting, being satisfied, going back. But in the boiler world, the boilers are generally able to handle the 2 demands at the one time. So if the boiler's up to temperature almost with the hot water circuit, if it's in mid position, it's not going to lose much. But officially, this is what we have. All right. So just remember that we motor open to the hot water circuit. So when you're looking at this diagram, can you tell me if that's correct?
It's motoring off the room stat, is it?
Yep, 100%. So it's going to be sitting in rest in hot water mode, which will just cause problems like the pump overruns and things like that. So perfect, well spotted. So that should really be 4 should be going into here, and the room stat should just be going into here. That's not the best picture, but I should really have it the other way. But yeah, basically what will happen is signal demand, so LED D6, that's our signal demand for an external heat source. That'll then energize, send 240 volts from here and energize this relay, which makes the contacts and basically sends power out. So, but you have to have power coming in first. So as long as that timer is sending that signal demand, if there's a demand at the battery, this relay will close and it'll send it back out to your zone valve. There's your link 3 as well. So that link 3 is fitted. So that's going to be expecting a low temperature of 65 degrees. Or its set point is at 65 degrees. So if you're got a flow temperature of 65 going into the battery, that's fine. If you remove that, the set point is now set to 75 degrees. So your heat source would have to be set to 75 as well, going into the battery. Okay. So IPV electrical connection. So again, we've got, it's a little bit different, but it's the same as the EPV that we just covered earlier. So you've got your four core, permanent live, modulating live, neutral and earth, charging links permanently fed, and you've got a 2 core going to your heat source. That's it. So there's not much difference there. Just things to remember, must be rated at 16 amps back at your supply, feeding your 16 amp minimum rated double pole isolator into your eddy or solar diverter. An important thing, that solar power diverter must have an AC modulating output as well, because we're an AC unit. So I know the Solar iBoost Plus is a DC modulating output. They used, Marlec, who make the Solar iBoost, they used to be AC modulating output, but they changed it. And I think there was a bit of a grey area where they didn't update their manuals or something. Because now, when you look at their current manual, it does say in the beginning, this device is DC modulating output, with a big cautionary signage and all that. Whereas they never used to have that. So we had a small window where installers were fitting a Solar iBoost Plus, which was DC output, and it was frying the whole electrics of the battery. And there was one instance where the breaker was actually fused itself, closed, and it couldn't trip. And then the whole system just fried. So yeah, be aware. AC modulating output. An IPV electrical system, it's the same thing, same as the Thermino I. So the charge and light sequence for your Thermino I is sort of standard one, as I say, that element LED will always be off. And you obviously have your flashing lights as you get up to temperature. If you ever get the element LED on, you know that there's a problem with that volt-free control circuit. So either there's a connection being made somewhere, or you've used a 4 core instead of a 2 core cable. So that's just something to bear in mind. IPV is a bit different. So kind of start backwards a little bit. You've got a full charge there, so 3 green lights, no element LED. You use 5% of your capacity, that unit's going to be looking for solar. So that element LED will be illuminated. It's not to say it's using any electricity. It depends if you've got a time boost set or any solar being generated at the time. And then once you get below your 85%, that's when your heat source can then kick in. So it's just a bit of advice that you can give your customers, because it is something that customers ask. Fault finding, I mean, the only time you're going to get any problems with overheatings with your IPV version is if the temperature sensor's pulled out. If the temperature sensor's pulled out in your Thermino eye, it's just never going to reach temperature. So it's just constantly going to give that signal demand to the hot water circuit, the zone valve. And then, yeah, the bar will be hot and it'll be heating. It just will never reach temperature. So just make sure it's pushed fully home.